Hey everybody. I am back in Kansas City and I am trying to make things work. I had to move over to my parents' house because my internet is not adequate for this. Anyways, I've got your assignments for this week and hopefully I can get this work. I've messed up about 4 times already, which is frustrating, not seamlessly in Florida. So we'll see. Hey, notice on Schoology, we've got 330, 331, 0401, and essentially, I forgot I need to do this, but I need to create some homework assignments. But let's go into this. Basically, you're going to be working through a worksheet. Last week we did conceptual work about balanced forces and unbalanced forces. And if I have unbalanced forces, I've got acceleration. The net force is in the direction of the acceleration. So now we're going to kind of get into the quantitative work, and that's what this worksheet 1 is about. I've split it up into 4 parts, or 3 parts, because there are 4 questions, and we'll go through 1 and 2 today. You'll do 3 tomorrow, and 4 on Wednesday, although they'll all be due when? Friday, okay? So let me get into here, and let's see if this will work. Now I'm going to nest this into an assignment pretty soon, but I'm going to go through videos first. So let me get the directions up first. All right. Basically 2 ways to go about it. If you're a hard copy person, you can print this worksheet and then take a photo when you're done with it. The other way to go about it, the other way to go about it is you can work on it on a piece of notebook paper. Just identify the number and the letter that you're working on, like 1A, 1B. You don't have to rewrite anything. Just make sure I know which section you're on. I can grade it that way. Part 2 is work on it electronically. Follow the link, right? So let's go back to the link. And then use Canvas or Draw or Keep, whatever that little note thing is, the bottom corner of your Chromebook. Create the free body diagram or do the mathematical work with setting up equations and just show your work and insert that picture into the diagram. Today I think I'm going to be doing screenshots on the webcam. We'll see if it works today. This will be try number 4. We'll see. So I'll go back to this. When you're in the assignment, this is your document. Okay, oops, I need to get up there. Oh, looky there. I've got 2 of them open. Okay, and once we get this sheet, all right, this is COVID Part A, you're just gonna make a copy, okay? Make a copy, it doesn't matter how you name it. I put my initials, worksheet number 1, Part A, just for my reference, okay? You can name it whatever you have to keep track of it. Okay. So now I've got this. I'll read the question and basically I'm going to do part A or 1 and 2, and then you're going to do those. You can reference the video if you need to, but let's walk through it. So I've got an elevator moving up at a constant velocity. As illustrated in the diagram below, the passenger has a mass of 85 kilograms. Construct a force diagram for the passenger, and then calculate the force the floor exerts on the passenger. So I'm going to redraw it so I can go up to the webcam. And keep this going. Yep, still recording. Hi, I'm in the reflection. There's reflections everywhere, folks. Hard to find a spot. So I'm just going to redraw it. Got the person right here. Now the tricky part about an elevator is they tend to look at the cab instead of the person. Remember when we did free body diagrams, we said we are doing a force diagram or free body diagram for the person. So we just want forces on the person, okay? So part A basically is a free body diagram, a force diagram. And what forces do we have on the person? Not the cab, but the elevator. So as always, the first easy one is force gravity. And then what other force do we have? Now, some people are tempted, well, I've got tension because it's pulling upward. Well, that cable is not attached to the person. That cable is attached to the cab, right? What's acting on the person? Well, the person is on the ground. It's a contact force. We'll call that force normal. The last thing we do on a force diagram is determine can we put any congruent marks on there, right? So what do we have? We have constant velocity. So what's that mean, right? It means forces are balanced. I can go at constant velocity if the forces are equal, right? So that is my force diagram, okay? Now part B talks about find the force acting on the person, right? Force of gravity, but from the floor, which is basically they're asking for the force normal. So I can put my force net, and this is the long way, right? Oh, sheesh. Force net, right, equals mass times acceleration, but we know acceleration is 0. Force net equals 0, right? That means my upward force equals my downward force. If there were more than 2 forces, this would be a little trickier, okay? So then I have force normal minus force of gravity equals 0. Force normal is positive because it's going up, and force gravity is negative because it's going down on the diagram. Remember this comes from the diagram. So what is force of gravity? Force of gravity, you guys remember this, is mass times little g. Little g was from our experiment where we measured the mass, and then we also noted the force. We found a slope of 10 newtons per kilogram. That's for everything on the planet Earth. Okay, we've got 10 newtons for every kilogram. So force of gravity, right, equals 10 times 85 kilograms, which gives us 850 newtons. Okay, so force normal. Do I have this? Oops, I don't. Force normal basically equals force gravity, which equals 850 newtons. That is the force the floor exerts on the person. So what am I going to do to submit? Good, I'm still recording. I'm going to do a quick screenshot. And I'm going to go back to my document, and I'm just going to paste it. Now I can adjust this a little bit so it fits. I don't have to. Don't have to worry about it sticking to 2 pages, but I like it to fit just because that's me. I'm going to go back to my camera. Then part B asks for the calculation, and I'll just put all this down there since I did the work. Now, most of you should be saying, I could do this so much faster because they're equal. I get that. Totally do that. But just show your work on how you did it. Okay? And then I'm done with number 1. Okay? Now I'm going to pause number 1. And basically what I want to do, or stop this video, is I'm going to create a video, but I'm going to put it in tomorrow's folder. So you're going to try number 2 on your own. And if you need help, you can go to tomorrow's folder, the March 31st folder, and see the video for number 2. Okay? I hope that gets you warmed up and able to get working on this worksheet.